Hey guys, I mentioned in the last video, or I think 2 videos ago, that right we have an integral. We've got integrating from a to b of some function f of x dx. We've got some function capital F of b minus capital F of a, right? And capital F, right, capital F of x, we sort of define as the indefinite integral, no bounds, on f of x dx. And I said a few videos ago that the fundamental theorem of calculus is that the derivative of this function, right, f of capital F prime of x, is equal to f of x. What that is that this integral function is the antiderivative. And that's a really interesting and beautiful point in calculus, and I'll have some videos proving this that I'll link in the description, but that's really not the point. The point is just being able, of this video, is to be able to apply this and use it and develop some rules for finding the antiderivative. So let's start, right? First of all, note that any antiderivative, right, is going to have an arbitrary constant, right? So, and that's just because, right, f of x plus c has the same derivative, right? The derivative of that is equal to f of x, right? Which is the derivative of capital F of x. So if we're doing a general derivative, or if we're doing a general antiderivative, it's always going to have this plus c, because if we take the derivative using the sum rule and the constants rule, we know that the derivative of this constant is 0, so I'll just get this is equal to the capital F prime of x, right? We should see that the general antiderivative of this is going to have the plus c. The only thing is, if we've got bounds, right, a and b, right, we know that if we're just, doing this, right, even if we have this plus c, we're going to have, capital F of b, which is going to have that plus c, minus capital F of a, which is also going to have that plus c, but it's, you're going to be subtracting that plus c. And so you're going to get c minus c. The constant does not matter for a definite integral, but it does matter for just finding the general antiderivative. And hopefully that makes sense. If not, do it on your own. You should see that if we have a function, right, let capital F of x equal some g of x plus c, right, you'll find that if we, plug in b minus that plugged in at a, right, for capital F of x, you'll have c minus c. That will be 0. The constant won't matter. So do it out on paper if you don't exactly get what I'm saying. The way I mentioned it, just let it be some function, then plus an arbitrary constant, right? So we've got this plus c. We know that we always have to have a plus c. And so let's look at some undoing of derivatives. Well, I know the power rule. The power rule is d by dx, right, of x to the n is equal to n x to the n minus 1. Well, it's not hard to show using this that the integral of x to the n dx is equal to 1 over n minus 1 times x to the n minus 1, and then plus c. So this is the power rule for integrals, and I would definitely write that down. And you can see, if you take the derivative of this side, right, we'll get n minus 1 here, and then we'll add 1 here, right? Oh, sorry, this should be plus. I apologize. My bad. This should be a plus. So we raise the power of x, right? And then we take this down, we subtract 1 from the exponent, we bring this down, it cancels out. So take the derivative of this, and you'll see that it is equal to this, which is our fundamental theorem of calculus. So the derivative of this side is the function inside the integral. It's the antiderivative. So hopefully you have that written down. Okay. So really, there's a lot of rules for finding antiderivatives. That's going to be a really big one. The only other big rule for antiderivatives that you're going to want to know, and then the rest of it I'll kind of help you along with, right, is well, there's a few things, but mainly integration by parts, which is a bit complicated in a way, and I'm going to actually make it slightly less complicated. For the sake of simplicity, I'm just going to do it in the form that we're going to need it. This is not like a formal, well, it is formal, but it's not like this is not a really advanced explanation of integration by parts. Right? So I've got the integral of some f of x times the derivative of g of x. Right? Ooh, gotta rewrite that. Right, and we'll actually see stuff in this form that we're going to take, that we're going to be taking the antiderivative of a function times the derivative of another function, right? Dx, right? So this is what we're taking, right? It's a product. But we know, right, this is a d. We know, right, that if I've got f of x times g of x, right, and I'll actually write it like this. I want to take the derivative of a product. I've got f of x times g of x, right? Well, the derivative of this is, we know from the product rule, f of x times d g of x by dx, right? And then plus g of x times the derivative of f of x. Or, yeah, dx, sorry. Right, this is a product rule for derivatives. So integration by parts, what we're going to get is, well, if I rearrange this a little bit, right, what I've got is I'm taking the antiderivative of this, right? So if I just sort of rearrange this equation, and I can actually do it just by the way I wrote this, become a minus sign, right? All I'm doing is just subtracting that from both sides of the equation, and I've got the equal sign here. What I'm doing is I'm taking the integral dx, right? I'm taking the integral dx of this entire equation. And so that's the integral dx of this minus the integral dx of this is equal to the integral dx of that. But this is, right, a derivative. And what's the integral is an antiderivative, right? So what we've got here, and I'll write this out. I'm going to erase this, and I'm just sort of going to rewrite it. We know from the product rule, just rearranged a little bit, that f of x, and actually I'm going to eliminate the of x because it's a little bit redundant, right? So f times dg dx is equal to, I'm going to move this equal sign a little bit down, is equal to f times g, right, the derivative, d by dx, of f times g minus g times df dx. Right? And now what I'm going to do is I'm going to integrate this entire equation dx. I'm going to have to take the integral of both sides. Right? We can do that because we're just doing the same thing to both sides. Remember the integral, there's a, I think I covered the sum rule of integrals. If I did not, just note that the integral of a sum, and this is, actually I don't know if I covered this, but the integral of f plus g dx is the integral of f dx plus the integral of g dx. Right? The integral of f dx plus the integral of g dx. Right? And same thing, there's a difference rule minus, right? But the more general thing is some constant times f dx. We can bring a constant out of an integral. So c times f integral f dx. Right? So these are two really important rules. This is the sum rule, right? And we can get the difference rule just by saying c is -1, right? And so this is, if this were, you know, f minus g, this would be plus the integral of -g dx, right? But the integral of -g dx, -1 is like a constant that we can take out, so it would be minus integral g dx. So that's sort of what we're doing here. And you can show that based off these two. So make sure you have these two written down. Those are very, very important rules. Hopefully I covered that. And again, you can look on, I'll have some videos and I'll have a document of all the rules that you need to know attached to the video. So I totally have that. So we've got this thing here, right? But what's the integral? This is the antiderivative. We're looking for the antiderivative of the derivative of f times g, right? The antiderivative of the derivative is just f times g, right? So this is equal to f times g minus the integral of g times df dx. Well, this is the integral dx. And this is our integration by parts formula, right? And it may look like it's more complicated, but the hopeful thing, right, is that this df dx, this integral, is going to be far more simple to solve than this integral, right? So, this is our integration by parts formula. You will see why this is so important, right? So if I've got the integral of f dg dx dx, right? This is integration by parts. Very important. You're going to want to know this formula. And I proved it using the product rule of derivatives. Hopefully you understand that proof. This is, But what about our plus c? This is an indefinite integral. Where's our plus c? And the answer is the plus c is in this integral, right? We don't need that plus c because this integral will have a plus c, and then it's gonna be our plus c, the same plus c, right? Hopefully that makes sense. There's not too much else in terms of integration. Really, the other integration that we'll have to do is going to be pretty easy using the rules that, either integration by parts or we'll have the sum rule, right? The constant coefficient rule, the power rule, and other than that, you'll see that it's going to be fairly simple integration for at least how far we're going into quantum mechanics. So that is really the rules of integration. So I will see you in the next video.